Howdy folks, this is Cowboy V2 again. It's been a little while. I've got kind of an odd project today. I was doing some remodeling for the missus in her kitchen, putting up some shiplap, and I have this PLS Laser Systems PLS 180 laser that I was using to set the shiplap all level. And I ran into a problem that called into question the accuracy of the laser. I was under the impression these are super durable, good, reliable lasers that, I'm not using this thing commercially. And anyway, the guy that was helping me out, he said, hey, why don't we check it against a level? And I said, well, this is way more accurate than a level. And sure enough, 6 foot level, this thing's out maybe 1/8 of an inch. I mean, really bad. And so anyway, I did a little digging around on the internet and couldn't find anything on how to calibrate this thing. The guy that I was with, he said, throw that thing in the bin. I don't think he's ever bought a PLS laser. This set me back $400 or $500. Not really into that. And so I did find some China laser calibrations on YouTube, but nothing on this PLS 180. And so I'm going to go ahead and pop this sucker open and see if we can figure it out. We'll compare it to that level back there. One other thing I want to note here, if you look real closely, let's see if I can get it to focus. Where is it? Ah, there we go. You see that little sticker there? It says made in China. I was under the impression that these were made in the USA until fairly recently, actually a couple of years ago now. I was interviewing a person, I'm not going to say who it was or what position, but I was interviewing somebody from the old PLS Laser Systems company who had left after, I guess, the original owner had died. And Fluke bought them, apparently. And they were originally made here in the US. And Fluke wanted to cut the cost. They're a big company. And so they decided they're going to send them over to China. Well, apparently they had some growing pains with getting that sorted out. And that person told me that they were having major QC issues. And they're not the same laser. So I don't know what the deal is. This one's made in China. It's not one of the originals. And so we'll get this sucker popped open and see what the deal is. All right, so first things first, I've got the laser on here. And you can see here, I've got the level is pretty much dead on. The laser, if you look, I've got it aligned with the bottom of the level rail. You can see it's just kissing the bottom of the right-hand side of that level rail. And then over here, if you look at where, let's see if I can get it to focus. There we go. If you look at where it intersects with that box, that's probably, 3/32 or so below the bottom of the level. I'm just doing this mainly to show you that it's out. And so we'll get this tuned up. I'm going to have to come up with some other way of verifying it, but this will get us at least part way there. Right now the laser is mostly junk, so I don't think I can hurt anything. All right, what do we got here? So we've got a soft case. Looks kind of like what I've got in my Fluke meter. Let's see if we can stretch this off of there. All right, that's part way there. Pop the battery case off. Alrighty, so if you look in real closely there, they're using these itty bitty teeny tiny little Torx tip screws, and maybe that's their way of trying to keep you out. Fortunately, I've got my dandy little anti-tamper screw tip set, and I think there's some micro Torx in there. That's a pretty small one there. Let's see if one of these will fit. Oh, wouldn't you know, that's the smallest one in the whole set. What is that? That is a T6. Okay, well that doesn't sound that small, but it's pretty tiny. Camera's not focusing super well. Anyway. All right, let's see what we got. All right. Whoa. Don't want to lose those screws. All right. 1, 2, 3, 4. Got them. All right. What do we got here? Is that serviceable? Probably pop this guy off first. All right. So that's the control board, I guess. How does that come out of here? Ah, you just pull it out. Okay. So it looks like what we've got. Here's the laser assembly and pendulum. And we've got this guy here. It's just a mount. Just sits here, I guess. Pop that in afterward. Set the case aside. Fancy. That doesn't look anything like the one that the dude on YouTube was taking apart. I'm sure this is one of those things where you avoid the warranty if you're doing what I'm doing. Okay, well, it looks like there's the adjuster screw that the fellow was messing with on his. It's just a little brass screw in there. Change the center of gravity on the pendulum here. You can see. All right, you know what? Let me reposition the camera. Okay, so it looks like the way that this guy works is there's a laser emitter somewhere in there. Not sure where. Got a couple of mirrors here that redirect the beam. But in essence, you've got a dual axis pendulum. You can see it can tilt right, left, or forward and back. And looks like, if we look in the bottom here, looks like there's maybe a neodymium magnet down in there. You can see right down there. And I imagine that probably helps to serve to dampen the movement. Now, I've actually dropped this thing a few times thinking it's designed for contractors. Those are guys going to be pretty rough with them. But the way that I'm seeing this now, I'm looking at this. This is not a high production part. This is kind of a little bit surprising. Usually in a mass production part, this would be die cast, you know, or some other high volume process. This is actually a chunk of aluminum that's been machined to get that shape, and it's actually kind of a complex shape. And I see some little filament wires here. I'm not sure what those are going to. Maybe to the laser emitter back there. But this is assembled like a kind of a high precision device, and the way that I see it now, I probably was making a big mistake dropping this thing, and that's, I'm sure, why it's out of calibration. So, moral of the story, your PLS laser is not built like a hammer. Do not drop it. If you do, you might find yourself where I'm at. All right, so I think I'm going to try plugging this thing in and get a little better idea of how it works. All right. So there we go. See, I got my horizontal beam there. And it was off left to right. Now that's going to be the mass adjuster screw. Should change that. But it also seemed to be off in this direction too, which I'm not really sure what's causing that. Oh, that's interesting. I'm wondering if the maybe the magnet in the bottom is used actually not to dampen its movement, but possibly to also somehow indicate that it's outside of the adjustment range, or self-leveling range, I should say. That way it shuts off the beam. I want to really look straight into this thing. What if I hit the other button? Okay, so now it's vertical. Okay, I see. I think there's actually a laser emitter in there, one in there, and one in here. And so this does the horizontal beam, and this one here does the vertical beam. And they have a different set of reflector mirrors to direct either vertical or horizontally. And if I hit this other button, let's see, then I get both, and that switches on both of the emitters, one there and one there. Okay, so I think I figured out how exactly it tells whether the laser is out of auto leveling range. And so I was looking at the pendulum assembly, and there's this little pin in the top inside of a hole in a plate, and there's a wire connected to the plate. So there's red wire here, and then there's a pin inside that hole that's on the pendulum. And so if you push the pendulum to one side, you see the laser turns off. You see that? And that's when that pin touches the plate and completes a circuit. I thought maybe the magnet in the bottom had something to do with it. I'm back to the opinion that the magnet's just there for dampening. And this pin is there to determine out of range. All right, so what I'm going to try to do here is, if you look at the green beam, you can kind of see it on the level there. I reposition the level, and it's low on the left side. And then over on the right side there, you can see it's almost at the top of the level. So there's a adjuster screw. It's a mass, center of mass or center of gravity adjusting brass screw inside of, whoa, not trying to pop this thing over. Anyway, inside that little bore right there. And so it looks like if you screw it in, it'll cause the beam to, excuse me, if you screw it in, it'll cause the pendulum to come to the left and the beam to rise on the left. And then if you back it out, it'll go the opposite. But we'll verify that in a second. Should be kind of intuitive. So, assuming that they're using standard right-hand threads. Okay, I got about 1/8 of a turn there. Probably a good idea to try not to short out any of these circuits on the frame of the laser. Wow, this thing is way out. Seems to be getting better, but I'm not certain. Looking at it further, I just discovered this rear access hole here. If you look inside there, let's see if I can get you a shot of that. Go get a flashlight. Okay, I got a flashlight here. It looks like inside there. Ah, there you go. Looks like there's another one of those adjuster screws through that back hole there. So that would adjust the angle this way. So I'll probably have to tune those two both. But it looks like this is doing the trick. I'll save you guys the time of dialing it in perfectly and then reassembling it. You guys can figure that out. But it looks like that's pretty much it. The two adjuster screws for the pendulum are this guy here. And that's for this direction, just changes the center of gravity this way. And then there's this other one here that goes this way that you access through the back of the hole. So I'm going to tinker with this a bit longer. We'll get this thing dialed in. Okay, actually, in messing with this thing a bit more, I discovered one more adjustment. I was having a hard time getting enough weight offset out of this one little adjuster screw for left or right. And I discovered that they actually put more of those brass set screws up top here, and they just go through this plate. And I think that you might, I think the intention of those is actually to be able to remove one or more, or even adjust them in or out to get additional weight offset. And by removing this outer one, I was able to get the weight to shift over to the right far enough that it actually did the trick. I have no idea what the factory calibration procedure is for this, and they're the kind of company that's not going to say, but this seems to do the trick. Appreciate you guys. Hopefully this was useful. If you're into more of this type of content, like and subscribe. If not, have a killer day anyway. Thanks for watching.